In this segment of our course, we will show you the procedure to use in installing and adjusting a typical Kingsbury-type thrust bearing. We will use the same bearing and vehicle you saw in the disassembly segment. The parts have been cleaned and inspected, all repair has been completed, and the needed new parts have been obtained. During the installation of the thrust bearing, the rotating assembly must be adjusted to its correct running position within the pump case. To do this, the top half of the pump case must be removed. Even though all of the parts have already been cleaned and inspected, some additional insurance may be gained by giving each part a quick inspection as you prepare to install it. The first part to be installed is this shaft adjusting shim. First, make sure the faces are positioned as they originally were. Then slip it over the shaft and seat it against the shaft shoulder. Next, install the thrust collar drive key in its key seat in the shaft. Make sure it is seated properly in the seat. Now, measure the height of the key, as the workman is doing here. Then, measure the depth of the key seat in the thrust collar. And compare the two measurements. The height of the key should be 3 to 6/1000ths of an inch less than the depth of the key seat in the thrust collar. The thrust collar is installed next. Make sure both faces are clean and are properly oriented. Then slip it over the shaft, onto the key, and seat it against the shaft adjusting shim. Secure the thrust collar with the lock nut. The workman scribed the thrust collar and the lock nut during disassembly, and he is now tightening the nuts until the two scribe lines coincide. A word of caution may be appropriate at this time. If, during repair, any metal was removed from the face of the lock nut, either face of the thrust collar or the shaft adjusting shim, you can see that the scribe lines would be meaningless. However, since no metal was removed from any of these faces, the scribe lines will coincide when the nut is properly tightened. With the lock nut properly tightened, our concern now is with runout of the thrust collar and the lock nut. The position of the pump rotating assembly is also of major importance at this point. In preparation for checking out these things, the workman first installs the bottom half of the base ring of the active thrust bearing, which is the inboard bearing on this piece of equipment. Then he inserts 3 thrust shoes in the base ring and rotates this assembly to the bottom of the bearing housing. He then applies oil to the thrust collar and the thrust shoes. He does this while the shoes are not in firm contact with the thrust collar, so the oil may enter between the two. Now he pushes the pump rotating assembly toward the inboard end of the pump until the thrust collar rests firmly against the thrust shoes. It can now be determined if the position of the rotating assembly within its casing is correct. By looking closely at the location of the impellers in the bottom half of the case, we can see that they are positioned correctly. However, if the position of the rotating assembly is incorrect, the correction will be made with this shim. For example, if the assembly is too far toward the inboard end, we would remove the shim and machine the correct amount from its length. On the other hand, if the assembly is too far toward the outboard end, a longer shim would be required. If you have any doubts about your piece of equipment, consult the manufacturer's manual or ask your supervisor. This is a picture of a centrifugal compressor rotating assembly, adjusted to its running position within its case. The alignment of the impellers with their diffusers is attained with the shaft adjusting shim, just as the pump rotating assembly is. Here's another example of what we're talking about. This steam turbine rotating assembly is adjusted to have the correct gap between the nozzle and the buckets on the first wheel, and the adjustment is done in the same manner as is the pump and the compressor. There will be some variations in the procedure, but the basics will remain the same. Once the workman is sure the rotating assembly is positioned correctly, he prepares to check the thrust collar for runout. As you can see, he is adjusting the foot of the dial indicator on the face of the collar. This task will usually require 2 workmen. This workman applies pressure to the end of the rotating assembly, keeping the thrust collar in contact with the thrust shoes, and watches the dial indicator, while another workman turns the shaft from the coupling end. There should be no run-out here. If there is, the collar will have to be removed and the cause of the run-out corrected. Another place where run-out could occur is the OD of the thrust collar lock nut. Remember, the ID of the outboard oil seal ring seals on the OD of this lock nut, requiring a relatively true running surface. Before the run-out is checked, however, the set screw should be tightened, as the workman is doing now. With the foot of the indicator on the lock nut, one workman watches the dial while the other turns the shaft. The total indicated run-out here should not exceed 0.02 of an inch. Excessive run-out would indicate some deformity on the face of the lock nut and would necessitate removing the nut and correcting the cause of the run-out. If the rotating assembly is removed for other work, these run-outs may be checked easier and with more accuracy if done on the lathe, as this workman is doing on a compressor rotating assembly. Once the rotating assembly is positioned and the run-out of the thrust collar and lock nut has been checked, the top half of the case may be replaced and the seal glands tightened before continuing with the installation and adjustment of the thrust bearing. The workman found during inspection that it was not necessary to remove this oil seal ring. If it had been necessary, he would replace it at this time and secure it with the bearing adjusting shim. This O-ring prevents oil from leaking by the oil pump bracket and should be replaced with a new one, as the workman is doing now. Once the new O-ring is in place, position the oil pump bracket in the lower half of the bearing housing and replace the bolts in the lower part of the bracket flange, but don't tighten them at this time. The next step is to install the base rings on both sides of the thrust collar. Remember, 1/2 of the inboard base ring was installed earlier, along with its thrust shoes. Now the workman is installing the other half of the inboard ring, making sure the leveling plates on the 2 halves are properly interlocked. He then installs the base ring on the outboard side of the thrust collar, again making sure the leveling plates are interlocked. Now the remainder of the thrust shoes may be installed. Before they are, however, check the babbitt surfaces once more to make sure there are no nicks or burrs on them. If there are any, no matter how slight, remove them with a scraper. We told you earlier in this course that the Kingsbury-type thrust bearing is designed to operate with a wedge of oil between the thrust shoes and the thrust collar, thus preventing any metal-to-metal contact during normal operation. An important part of this design is the beveled radial edges of the thrust shoes. The leading radial edge of each shoe must be beveled to permit the oil wedge to form, and since these shoes are designed to operate in either direction, both radial edges must be beveled or chamfered. Cleanliness is very important to the life of the bearing and should be stressed throughout the assembly procedure. The babbitt surfaces of the thrust shoes, for example, should be wiped clean before they are installed. The babbitt is not clean if it discolors a white towel, as this one is. Flood the thrust collar and base rings with oil. Coating the bearing components with oil will prevent them from rusting while the equipment is waiting to be put into operation. Now install the remaining thrust shoes on the inboard side of the thrust collar. Then install the shoes on the outboard side. The base ring must be rotated to accomplish this. It cannot rotate all the way due to the base ring key. However, the key will permit enough rotation to allow the shoes to be inserted into the base ring. After all of the thrust shoes have been installed, rotate each base ring until the base ring key is positioned to enter its locating notch. In order to check the bearing operating clearance, it is mandatory that the top half of the bearing housing be aligned and secured to the lower half. Otherwise, our indicator readings will not be accurate, because the leveling pads, unrestricted at the top, will not level the shoes. Our next step, then, is to remove the protective covering from the sleeve bearing. Then inspect the machine surfaces of the bearing housing for nicks and burrs, and wipe it clean. Now place it in position on the lower half of the bearing housing. Take care that the inboard oil seal ring is not damaged, and make sure the top half is all the way down on the bottom half. If something interferes with it going completely down, don't try to force it. Remove it and find out what is interfering. Once you are satisfied the upper half of the bearing housing is seated properly, install the dowel pins. Again, make sure they are free of burrs and are clean. These dowel pins align the two halves of the bearing housing, and a burr could cause improper alignment of the two halves. Install 4 bolts, evenly spaced, and tighten them snug. There is no need to replace all of the bolts at this time. You'll see why in a few minutes. Replace the bolts in the upper part of the oil pump bracket flange. And using the crossover method, start tightening them. Check the axial movement of the rotating assembly intermittently to make sure the thrust bearing is not being clamped as the bolts are tightened. Once the oil pump bracket bolts are tight, mount a dial indicator in preparation for checking the operating clearance of the thrust bearing. In this instance, the workman has mounted a magnetic indicator stand on the end of the shaft and is adjusting the foot on the oil pump bracket. He then places a pry bar between the seal sleeve lock collar and the seal gland and carefully moves the rotating assembly toward him to its limit of travel and zeroes the dial indicator. Then he moves the rotating assembly to its limit of travel in the opposite direction and checks the indicator reading. The reading on the dial indicator is the amount of clearance in the thrust bearing. This is normally referred to as end play or lateral. Refer to the specifications in the manufacturer's manual to determine if the end play is satisfactory. If the end play is within the limit specified by the manufacturer, proceed with the remaining assembly. However, if the end play was either too much or not enough, some alteration to the bearing adjusting shim will be necessary. To do this, remove the top half of the bearing housing and the oil pump bracket from the bearing housing. Then the shim may be removed from the bracket. Let's take the situation of not enough end play first. This means that the bearing adjusting shim is too thick and will have to be machined to the correct dimension. This can be accomplished with a surface grinder, as the workman is doing here, or with some other shop machine, such as a lathe. If the opposite situation exists, too much clearance, a thin shim of the correct thickness can be placed between the oil pump bracket and the bearing adjusting shim, or a thicker bearing adjusting shim can be made. You will have to evaluate the situation and make the decision. Your supervisor will be glad to help if you are in doubt. Once the end play is satisfactory, replace all of the bolts in the top half of the bearing housing and tighten them. The remainder of the assembly procedure can be completed now. The workman is installing the oil pump after first installing the pump coupling. Since there is much variation in the oil supply system from one piece of equipment to another, we won't go into detail here. Just make sure that your assembly is correct. Refer to the manufacturer's manual or ask your supervisor if you are in doubt. The only remaining task is to place this deflector in its original position and tighten the lock screws to secure it in this position. That completes the disassembly, inspection, reassembly, and adjustment procedure of a typical Kingsbury-type thrust bearing. The procedure we showed you was for this particular type bearing installed in this particular piece of equipment. You will encounter many variations to this bearing, and they will be installed in different types of equipment, which will require some variations in procedure. However, the basic procedure will remain the same. Just remember, when in doubt, refer to the manufacturer's manual or ask your supervisor. We have some questions for you now. and exercise number 4 in your workbook.